we are given with k sets of observations. The sample sizes are n1, n2, etc. up to nk. What we have to check is whether these samples are drawn from populations having equal means. For checking that, first of all, we assume that our populations are normally distributed with means mu1, mu2, etc., μk, and also the variances of all these populations are the same. See the layout of the given table. We have included the population means to each row and the row sums are computed for each row. The data as a whole represents variability. This variability has two possible sources. The variability within a group is unexplainable. This variation is also called random variation. On the other hand, the computed row totals may also be different for different groups. But this variation is explainable. A factor contributing to this variation can be the different population means of the parent populations. So if we try to assess the total variability present in our dataset using some measures of dispersion, we can see that the total variability can be decomposed into two factors. Total variability present is equal to the sum of variability due to random or unexplainable causes, and variability due to the difference in population means. For example, if the measured value of total variability is 1000, out of which the random variation has a measured value 250 and variability due to difference in population means has a measured value 750, it is very reasonable to suspect that the difference in population means is significant. Using this idea, we can form an F statistic as the ratio of the estimated variability due to random causes to that of population mean difference. This statistics has been shown to follow an F distribution under some mild conditions, and it can be used as the test statistic. It is conventional to present the computations in a systematic table called ANOVA table. The formulas of computations are quite messy and the computation is very tedious. So we omit the computational procedures and leave that job to Excel functions. The MS column denotes the estimated variances corresponding to the two sources of variation, namely random variation and variation due to difference in population means. From the MS values, we see that the variability is larger in the between groups category as compared to within group category. We make the F statistic by taking the ratio of these two variance estimates and compare the value obtained in F column with the critical value given in F crit column. Note here that Excel gives us one more value called p-value. We are not going to discuss the technical aspects of p-value here. But in a layman point of view, we can use the p-value for making a conclusion. That is, if the p-value is less than the proposed alpha value, we can reject the null hypothesis. Otherwise, we have to accept the null hypothesis.